Thank you everyone for joining today. We will be continuing Jeffrey Wang's presentation of the Learn DAX Part 2. I guess without wasting any time, I'll give Jeffrey the mic and the floor.
Okay, thanks, Jason. We'll continue from last time. This is the last slide I talked about at the end of the last presentation. And today we're going to continue to go over DAX. Last time we went over a short history and the main concepts in DAX, the row context and the filter context, and the different categories of DAX functions, and the different usage of DAX in as measures, calculate columns, calculate tables, and the row level security expressions, and the important calculate function that allow you to manipulate the filter context and convert from row context to filter context. Today we will be going over some common examples, especially some of the common issues DAX users tend to run into. I'm going to show you some patterns and what are the pros and cons of each approach. I know we reserved about 2 hours for this presentation, but I don't think we need that much time. We reserved the 2 hours just in case we need a little bit extra time. I think 1 hour should be sufficient. So let's go to, okay. As we all know, the most powerful feature of DAX is to create measures, right? Measure is a dynamic expression that can be calculated on the fly in the report layer that can react to all the filters set by the users. And the calculate function is one of the primary functions for people to write DAX measures because it's used to change filters that's set by the users. And let's first look at a very simple DAX calculator statement. The purpose here is simply to say, I want to calculate the total sales in the United States. Right? So regardless of what the filters are on the report, I want to calculate the total sales in the United States. So here are the two common ways I see people do this. One way is you say calculate sum of sales amount where the country equals United States. This is one way to do it. And here's another way I see DAX users often write, that is to write calculate the sum of sales amount, filter the geography table, and the country equals United States. And I see people arguing about which way is better, and let's see. And are they equivalent? They seem to be equivalent in most common cases. So let's see how they actually work in a report. So let me switch to the PBX file I've created beforehand. Can you see my PBX file?
Yes.
Okay, that's great. Okay, so in this simple report, I have created a couple of measures. The first one is simply total sales. That's the sum of sales amount. And then the second measure is I'm using the first syntax. That is, here I have to switch to here. So I'm using the first way to do it. That is simply saying geography country equals United States. So this is the first way for me to set the filter. And then I create another measure, US sales 2, and nope. And I'm using the second common way of setting the filter. Filter geography table column equals United States. So if I add these two measures to a report, and here, if I simply in the report, I'm showing for all the different years, the total sales in that year, I can add the US sales 1 to it. It works. It shows me the sales in the United States in different years. I can add the second way of doing the same thing. US sales 2, I'm getting exactly the same numbers. So that's why I've seen many DAX users using depending their personal preferences, using one of the approaches to set a simple filter in a DAX measure. But in reality, these two DAX measures have different semantics. They're doing different things. So let's go to the second report. In the second report, I'm showing you the total sales for different countries. So you can see I have six countries, and the United States sales is about $9.4 million. So now let me add the same two measures to this report. First, let's add the US sales 1. And that's working as expected, right? So we said regardless of the current filter, which means that regardless what the current country is, this measure always only return the US sales, which is exactly roughly $9.4 million. So what if I add the second measure to it? And how come it only return the sales for the filter is United States? I'm only having the value for the United States, and for all the other rows, they're all blanks. So that tells us that these two measures are actually behaving differently. And before we switch back to the slides, let me show you a third way, which is actually equivalent to the first way. Which is I call the US sales 1.1. If you look at this expression, it says filter all of geography country where country equals United States. So this third way is also using the filter function just like the second way, but instead of geography, it's saying all of geography country where country equals United States. So before I leave, let me first add the third measure to the second report where it doesn't work. You can say, okay, the third measure works exactly like the first measure, right? It returns the sales in the United States, regardless of what the current country is. Does it also work in the first report or over different years? Yes, it does. So all three measures return the same results when I'm grouping by year, but the second approach returns many people say wrong results when I'm grouping by countries instead of grouping by year. So let's go back to the slide. Okay, so what's the difference here? As it turns out, DAX in DAX, there are many expressions that are filtered by the filter context. Okay, so what type of expressions are filtered by the filter context? And here, I'm showing you a few examples. There are many other examples. Okay, so for example, if I say count rows of geography, where geography is a table name, then the yellow, the highlighted part is filtered by the filters in the filter context. So the geography country, the geography table here is not the full geography table. It's not all the rows in the geography table, but rather it's the filtered rows of the geography table. Which filters? It depends on whatever filters you put on the report. And in the previous example, if the filters are year, then those filters have no effect on country because the filter is from the data table, and the date table does not filter the geography table. Therefore, those filters, even though they're present, they have no effect on the geography table. But in the second report, when you have countries as filters, then countries do filter the geography table. So the simple fact of writing a DAX table expression by itself, a table name by itself, does not mean I'm fetching all the rows of this table, but rather I'm fetching all the filtered rows of this table. And the second common example is I can use distinct of a column name. For example, if I say count rows of distinct geography country, what that means here is I want to get the distinct values of the country column after the filters are applied. So I'm first filtering the geography table, and then for the surviving rows, I'm getting the distinct list of countries. And finally, the count rows function will just return the count rows of. Basically, the full expression is returning the filtered list of countries, the number of a filtered list of distinct countries. Similarly, the value function, the value of a column, that's pretty much the same thing. So values of geography country means give me filtered list of distinct countries, and then I will count the number of them. The difference between values and the distinct I'll talk about in the following slide. Here's another very common DAX expression, has one value, geography country. It literally means after you apply the filters to the geography table, get the list of distinct countries to see if there's exactly one country left after the filters are applied. The is filtered of a column name means do I have a filter directly on this column? It's basically a way for you to detect whether there is a direct filter on this column. By the way, in DAX, many people says, why do we have the distinction between the aggregate functions and the X version of the aggregate functions? For example, sum have a sum X, and min and min X, max X, count and count X. Some people say, oh, the sum functions are more performant than the X functions. Actually, sum is simply a syntax sugar for the X version. So sum of a sales amount column is literally equivalent to, it's a syntax sugar for sum X of the sales table, comma, and then the expression is a sales amount column. Because the sales table is a table name by itself, as I have said, that means it's not the full sales table, but the filtered sales table. That's why if your measure expression is simply sum of sales amount, then it will return the filtered sum of sales amount. That is exactly because everything in all the direct table name in a DAX expression, it actually means a filtered table. So for this reason, if we go back to our original expression 1, 2, 3, the second expression, filtered geography countries equals United States. The geography here, you can see, is a table name by itself. That's when it's a filtered table. So this geography table is actually the filtered geography table, while the first expression, geography country equals United States, is equivalent in DAX to the third expression, filter all of a geography country, where country equals United States. And all, the key word here is all. All means unfiltered. So when I say all of geography country, that means give me a distinct list of countries from the original table without ignoring any filters on this. So the all of a column means unfiltered column, while the filtered geography, comma, country equals United States means a filtered table, and then country equals United States. And the first expression is a syntax sugar for the third expression, so it's equivalent to with all around the column name. Therefore, it's the unfiltered country. So with this knowledge, if we go back to see the report, it now makes sense why in the third report why at US sales 2 many of the row values are blank. It's because in this case because the expression itself is a filtered geography, so the geography is first filtered by the current country, which is Australia. So in this row, when I'm calculating this measure, I first filter the geography table to Australia, and then I'm gonna do a additional filter on top of the previous filter the results, which is I want to say for any surviving rows, I want to further filter by country equals United States. So this double filter produce an empty result because you cannot be the country equals Australia and also country equals United States. As a result, the filter expression produce an empty filter, therefore you get an empty sum of sales amount. Similarly, you get an empty for Canada, empty value for France, Germany, United States, and you only get a value for United States because the United States will first filter the geography, and then you get all the rows belong to United States, and then you filter it again, which is a country equals United States. So it doesn't change anything. So the final result of this expression, filter geography comma country equals United States, for this particular row is all the cities in the United States, and then this new filter is used to filter the sales table. That's why you get the sales in the United States for this row. While for the other two measures, it basically says regardless of what the current filter is, I'm gonna use the unfiltered United States to get the United States, and then I'm gonna replace this filter. So for the first measure and the third measure, they work because first they produce a filter expression for country equals United States, regardless of what the current filter is, and then the new filter is used to override the existing filter to replace it by the new filter, and then that's why we get the sales in the United States, regardless of what the current country filter is. That's how it works. So let's go back to the slide. So as I said, index, if you put all around a country name, or all around a column name, and then all around a table name, or all around a column name, that means the unfiltered table or the unfiltered column. And when you set a filter, sometimes you do want the double filter to you do want the double filter semantics. But for many users, if you are not sure which semantics you need, do I need the all semantics or I need the filtered semantics? If you are not sure, always use the all one, because that should be your default option. This has the minimal impact, right? First of all, it's a disk expression. It can be evaluated independent of the existing filters on your report. So it tend to be fast in a sense, right? Because you're evaluating expression regardless of what the current filter is. While this expression, you have to say this filter actually changes based on which row you are on. So we have to evaluate a different filter, produce a different results, and then use the different results to calculate the sum. That's more work, therefore can be more expensive to do. While this one is an independent expression, it doesn't care whether the current filter is. It always produce country equals United States, and then it will be used to override whatever the current filter is to calculate this sum. So you can think about it, even semantically, this is a cheaper expression to do. And also it has the minimal side effect. Many people would know that this expression actually returns all the columns in the geography table, not only the country column. Because when I say geography, it's a table name, and by default, an index table name include all the columns in this table, and it can be very expensive, and also it can be has many side effects when you have so many extra columns. While this expression only returns a single column, because I'm getting the list of individual countries. So this expression tend to have a minimal side effects compared to this expression. And so if you are not sure which one you want, I would just use the first expression, which is the shorthand. Simply say column equals a value. That has a minimal side effect. And you should only use the second one when you really know that you want this double filter semantics. Let's look at another example. And that when you write a filter expression that actually is filtered by itself by the surrounding filters in the report, it can have performance consequences. Let me show you some concrete examples. Both expressions I've seen from actual user reports. So the first expression is one user say, on my report, I want to select a product, but then I want to count all the customers who bought the other products. So I want to get the count of customers not who bought the product I selected, but who bought the product I didn't select, who bought the other products. So he came up with this expression. There are different ways to do it, and depending on the configuration of it, I'm just saying, I didn't say this is the most efficient expression. I'm just saying this is one way to do it. And for a reasonable size model, it works just fine. So what this user came up with was, I want to calculate, by the way, the user wants a distinct count of customers. So the user says, I want to get the distinct count of customer key column. And then he used the DAX except expression, which is like the set subtraction. I first get all the products, and then he cleverly used the table name by itself. We already know that the table name by itself means filtered, right? So I want to get the currently filtered product, which means currently selected product. So I want to use the all product to subtract, to minus the selected product. What does this whole thing give us? It gives us the unselected products. So basically anything other than the selected products. And then I want to get the count of customers who bought those products. So it's a pretty smart expression. It's also fully dynamic. And the second expression is one user, he wants to say, I want to get the distinct count of customers who bought some high cost product. So the way he get the high cost product is he want to get the best, by the way, he want to get the selected high cost products. So he has some filters that can narrow down the list of products. So that's why he used the values of a column function. The values of a column means I want to get the selected products. And then for their cost, I want to say it's high cost. Let's say greater than certain number. And then I want to get the distinct customers who bought those products. So I'm going to go back to the desktop to show you how the first expression works. But both expressions, I want to put it here to show you examples where the filter expression is actually dynamic. The filter here, the first part is the except function. The second argument is a table name by itself. That means it's a filtered product. And the second calculated expression, the values of a column function means filtered column. So both are dynamic value filters. And in this particular case, because the measure itself is doing a distinct count, it has some performance consequence. Right? And so that means I want to get the distinct count for this filter. And since the filter itself can change depending on the current filter on the slide, then we will see that the computation can become quite expensive depending on the size of your model. So let's go back to the desktop. So here I created a few measures. And so the first measure, I said a simple count. Notice that this is a count, not distinct count. Okay, I'm just getting the count of customers. Another measure, I said number of customers, other products, means I'm getting a count, not a distinct count of, I'm using the except pattern to say, I want to get a count of customers who bought the non-selected products. And then another measure, this time I'm getting the distinct count of customers. This one I didn't change filters, therefore this is the distinct count of the customers who bought the selected products. And the fourth measure, similarly, is I'm getting the distinct count of customers who bought the unselected products. So if effectively the four measures is count of customers who bought the selected products, count of customers who bought the non-selected products, distinct count of customers who bought the selected products, and distinct count of customers who bought the unselected products. And in the first table, you can see I get the let's say my report is showing the different colored products, right? So for different color products, I want to say how many customers this is who bought each colored product, and how many distinct customers who bought the product of that color. You can say the distinct count is less than the count. That makes sense because it will remove duplicates. So now let's see what if I use the other measure that the other two measures. One is using the count of customers who bought the other, basically not this color. And if I add it to the first report, I'm going to get for the first row, I'm going to get the count of customer who bought the non-black color, the who bought product which is not black color, and then not blue color, not gray color. Okay. For the third report, I'm going to add the distinct count of customers who the distinct of customers who bought the non-black, non-blue, non-gray color. So the middle one is the count. The right one is the distinct count. Let's see how the difference in their performance. Remember, in this case, the filters will change, right? Because as I said, the filter will change from color to color. This color is on the product table, therefore it will filter whatever the current selected set of products will be. And so that filter expression, that accept expression will change from row to row. Before I do that, I've already connected a SQL Server provider to this report, so I can see some under the hood queries generated by the DAX engine to calculate both expressions. So I go back here and let me clear the trace so that we can focus on the new query. So let's first go to the mid table. The first one I'm going to add is the count of customers who bought the other products. I add it here. It's pretty fast. And if I look at the trace, right? So there are two queries and then a bunch of called verti-pag queries events in the middle. You don't have to know all the details. The two queries, you can actually kind of understand what it means. It's, let me zoom it in. So it's using a DAX expression called summarize columns. If for people who are already familiar with this function, it literally shows you the list of customers, the list of filter, the list of group by columns, the list of filters, and the list of measures you want to calculate. And in this particular case, I don't have any filter. I just have one column, the product color, and one measure, number of customers who bought other products. And the verti-pag engine is the verti-pag SE query events. All these events are the number of internal queries the DAX engine have to send to the verti-pag engine in order to produce the final output. And you don't need to know the exact meaning of them, but you can just have a general idea that we send roughly, you don't have to worry about this 10 and the 10, the subclass. Those are the sub-events. So you only have to look at this 0, 0, 0, 0. So in order to calculate that query, the DAX engine send 4 verti-pag engines. Verti-pag engine queries. Each verti-pag engine query you can think about is a table scan. Okay, so now we need to actually do a scan of the table in order to produce the result. And now let's go to the second one. So let's go to the third report. And this time, instead of adding the count of customers who bought the other colored products, I'm going to do the distinct count of customers. It's still pretty fast, and the numbers are slightly smaller, which makes sense. As always, distinct customers should remove duplicates of the customers. And but if you actually look under the hood, you can say, wow, that we see a lot more VertiPaq engine events. A lot more. All right? And the query itself, if you look at the DAX query, it's still using summarized columns and has only one column on the report, which is a product color, and then one measure, that is a distinct number of customers who bought the other products. And why there are a lot more events is simply because DAX engine is pretty smart in the sense that count is an additive thing. By additive, it means because the report will change from product color to product color, but the DAX from product to product, but the DAX engine is smart enough to say, okay, I can lower the granularity, send a single query to fetch all the different products, because the product filter will change from row to row. But I can just go down to, for example, I can go down to the product key level and get all the products and then roll up their cells, and then when I go back to the DAX engine, I will dispatch those results into different colored buckets, and then I can do an aggregation of the result for each bucket. But for distinct count, we no longer have the luxury, because the distinct count is, you cannot use a partial aggregation. Distinct count, you have to go to the leaf level, right? You have to remove duplicates. So for distinct count, the DAX engine has to send multiple queries back to the VertiPaq engine each time to get a different distinct count. So it cannot piggyback, cannot batch all the different queries into a single one. So distinct count with changing filters can be a very expensive expression, depending on how large your model is. In this presentation, of course, we don't have time to wait minutes for a query to come back, but as long as you understand this particular pattern that you're calculating, if you find yourself calculating a distinct count with a changing filter, a filter that actually changes from row to row inside your report, then depending on the full size of your data, it can be potentially a very expensive calculation. Let's go to the next slide. Okay, so let's look at another common query pattern that that can cause some side effects that throw people off in DAX. Okay, so one of the powerful feature of DAX is you can define measures, many different measures, and they build on top of each other, right? So here is a very common example. Some people say, I want to define a measure just to get the current date. Okay, so there are different ways to do it, and the way this particular say, okay, I want to define a measure. By the way, this current date is a measure in this example, and I want to say I want to get the currently selected date. Some people use a min, some people use a max, and so in this example, we use a max of the date column to get the currently selected date, and then we know that there are different ways of doing time intelligence functions. We can here I'm showing you a manual way, even though many people just use the total Y2D function to do the same thing. The reason some people do it the manual way is because they want to put in some other filters. Sometimes they don't want to. They want to, their Y2D is not the calendar Y2D, but one of those retail calendars that they have to do the Y2D themselves. So people for all kinds of reasons need to write their own version of Y2D. So I'm just showing you, you can do it using the calculate function to do your own Y2D, saying, let's say I have a measure called the total sales. So I want to say calculate the total sales, and then I want to filter the date column. And this time we smartly use the all of date. Remember, that's a good thing. If you're not sure what you're doing, you're just doing all of date. And then they said if the year of the date is equal to the year of the current date, remember we have a measure that can give you the current date. So if I say the date is equal to the current the year of the current date, and then the date is less than or equal to the current date. So we're in the same year, but I want to get all the dates from the beginning of the year all the way to the current date. And then this will give me the list of, for example, from January to today, all the way to today. And then I use this as a filter to calculate total sales. That will give me the sales from the beginning of the year all the way to today. Okay, so this works. So let's see how it works in the actual report. Go back to desktop. So here I have a report, right? I already added two columns, the year column and the month column, and then I'm showing you the total sales. And now let's add the Y2D sales to this report. So there are different ways. So first I want to show you, I do have the current date. The current date is simply using the max of the date column to extract the current date. And then I have defined the two Y2D. And let's first see the first one. The first one is what I just showed you. It's basically saying I want to calculate the total sales, filter all the date column, and then the year of the date has to be the year of the current date, and then the date has to be less than or equal to the current date. So I'm in the same year from the beginning, January 1st, all the way to the currently selected date. It should work. Let's see. If I add this measure to the report, it doesn't seem to work because it's returning exactly the same number all the way across. Okay, and why? Why do we have this problem? If I go back to the slide, here's the problem. Measures index automatically pick up all the filters in the surrounding context. And so in this particular example, by using the measure name directly here, it's actually saying, I want to be filtered by everything in the report plus whatever the current date is in this iteration function. Since the filter function belongs to a group of functions called iteration functions. It basically takes all the dates, going them one date at a time, and then I check this predicate. But when I'm evaluating all this big predicate expression, there's some measure references in there. And each measure will be filtered by the current row in the iteration function. So this current date is going to be picked up by this date in addition to the whatever the outside date is. And so that's not what you want, actually. Because what you want this current date is you want to be filtered by whatever is on the report selected current date, but you want to ignore this date, because this date is I want to produce a different date, right? So I want to say for all the dates that's less than or equal to the date selected on the report. So this is a very common thing. Many people put a measure inside an iteration function. So filter is an iteration function, sum is an iteration function, sum x, all those x functions are iteration functions. Last time, if we go back to last time, we said that there are many DAX functions inside by the SQL, and many of those SQL functions, they produce iteration functions, such as add columns, top n, filter, and all the like sum x, concatenate x, average x, and so many of these SQL style DAX functions are iteration functions. Iteration function means that they have they are scanning over a table expression, going row by row, and evaluate something else. And when you are evaluating something else, if you have some measure expression on there, those measures will be affected by the current row in the current iteration. That may or may not be what you want. And in our current case, this is absolutely not what we want, because our current date, what we really want is we want to pick up the current date in my current report and save it. But I don't want that to be changing for each row in my iteration. So the way to do it is you can use the DAX variable. So I'm still using the measure current date, but I first evaluate it before I enter the iteration. I just say, okay, I want to get the current date based on the current report filters, and then I save it into a DAX variable. Once you save it, it no longer changes. And then inside my iteration, I'm still doing the same thing. I want to filter all of the dates, and then the year of the date has to be year of the variable, which is the selected date, and then the date itself has to be less than or equal to the selected date. Because now the selected date, I'm using a DAX variable that's evaluated before I enter the iteration. This measure no longer is affected by my current filter in the iteration itself. So let's see how it works out. We go back to the report, and I have created a measure called Y2T sales 2. This time I'm using the variable to pick up the date and save it, and inside the iteration I'm using the variable instead of using the measure. And now if I add it to my report, and I can remove the first one, which we already know doesn't work. And you can see the report is actually works. Right? So December is the December, and January is the same as the total sales. February is the sum of January and February. March is the sum from January, February, March. Same thing for April, for May. It keep going up until December, and then in January of 2012, it goes back to January total sales. So this expression works. Go back to the slide. So this is another common pattern you may want to pay attention to, that you should be very careful when you use measures inside the iteration functions. Again, sometimes that's really what you want. For example, you can define a measure, let's say total sales, and then you can put it inside the average X function. Average X, you can go over a list of something, and then you do want to say for each row, you want to use the measure that's actually filtered by the current row in the iteration in order to calculate the sales for that particular, say average over years, for example. Say for each year, you do want to the measure total sales to be filtered by this year, and then you go over all the years and then do the average of the final result. So sometimes you do want to put the measure inside the iteration function. You just have to do it knowing what consciously, instead of inadvertently using a measure inside in the middle of iteration function. All right. Next. So Palang, we talk about Palang. Palang is a very special thing in Microsoft BI. It has always been very special. Okay, it's special in many different ways. So I'm going to just talk about the three important aspects of it. First one is all the DAX filters, all the DAX visuals has an implicit filter. You don't have to do anything. It's implied that is all the Power BI reports and all the Excel pivot table reports by default will. You can drag some columns to it. You can set some filters. You can drag some measures, and by default, they will have an implicit filter. We call it a non-empty filter. That means I want to remove any rows where all the measure values are blank. So that's an implicit non-empty filter. And the second is in DAX, we will add something called a blank row to dimension tables if you have a referential integrity violation. What is a RI violation? RI violation basically is, for example, in many corporations, the dimension tables, they belong to the they call the master data, right? They are managed separately from the transactional table, which are the fact tables. So the fact tables can have in some corporations, it takes a while for, let's say you have a new product, it takes a while for them to enter a product catalog to be added to the product table, while any sales of this product, they need to be immediately reflected in the transaction fact table. So the fact table can have more products that have not been even added to the product table yet. In those cases, we don't, in Microsoft BI, how do you join between the fact table and the product table? And in some other BI products, they want to do it, say, I want to do an inner join, or I want to do a left outer join, right? I want to keep, if I want to keep track of all the cells, regardless whether the product has already been added to the product table, then you have to do a left outer join. But if you only want to show reports that actually have a real product name and the product other attributes, then you want to do an inner join. Power BI is very powerful in this regard. It gives you the flexibility to do whatever you want. You can do inner join, or you can do left outer join. You don't have to predefine the join. Many other products force you to pre-select a join. So if you want to do the other one, you have to you pretty much have to build a different model. That's too much. Power BI allows you to build a single model, and then you can at the query time you can switch between which type of join you want. But how do we do that is because in Power BI you are not joining the table beforehand, right? You are importing the table individually. So each table is all by itself. You can query the table all by itself without requiring the join at all. That gives them is make Power BI super flexible. So the way we do this is when we import the data, because then we know when we build the relationship between the transaction table and the dimension table, then we know that if there's a mismatch between the two. Do I have some transactions in the transaction table that don't have the corresponding, let's say, product key in the product table? If that happens, we will add a blank row to the product table. So when we materialize all the relationships, we also detect whether there is a RI violation across the relationship. And when so, we will automatically add a blank row to the one side of the relationship. This way, in the report, you will see, some people say, annoyingly, you will see a blank value. That's actually an indication of something real in your data. That means in your data, there's some mismatching between the two sides. That may be intentional or maybe unintentional. It's a hint for you to find out what's going on there. And the third thing about the blank is how we deal with individual blank values. Let me go back to this later on. I want to show the example of the first two cases. So we go to desktop. Okay. So in this case, I have a. If you look at my schema, there's a lot of other tables in there. How do I zoom the schema? So if you cannot see everything, and you will see that in the product table, I will have, let me zoom out. Where's my zoom key for my view? I cannot see. So you will see that, maybe it's just easier to see it here. So for my product table, it's actually connected to the product subcategory table and the product category table. Okay, so in this particular example, instead of having a single product table that has the category column and the subcategory column, I actually have the product table connect to the product subcategory table, and the product subcategory table connect to the product category table. So even though none of them is a truly transaction fact table, but they are on a they have a many-to-one relationship, right? There are many products in a single product subcategory, and there are many product subcategories in a single product category. So the same principle of RI violation still apply here. You may have some products which their product category has not been added yet to the product category table, which actually is the case here. So I want to say for for each product category, how many products are there. So you can just add the product name directly to the report. And instead of showing the individual names, I want to just say count of products. Let's do a simple count. Okay. So you see, in this case, I say for the 4 categories, I get their count 35, 125, 48, and 189. But I have another count, which is 209, that doesn't have a product category name. Why is that? It's exactly as I said. We have some new products being added to the product name, but in this particular database, the corresponding product category has not been added yet. But we don't want to lose data, right? So the actual product table do have 606 products in there. So I don't want to lose the count of them. That would be very confusing to the user. So Power BI is very smart. It automatically adds this blank row to you to say, okay, and we have 209 products that don't have a corresponding product category. So this is the example of a blank row example. So this blank row, we have automatically added to the product category table. In this case, it's on the one side, right? Product category is a dimension table of the product table, an indirect dimension table. And let's look at the second report. In the second report, I'm adding, for each product category, I want to add the total sales. The first thing you see is that on the left, there are 4 product categories. There are actually 5 product categories. One is the blank one, and then there are 4 named ones: accessories, bikes, clothing, and components. On the right, when I add the total sales to this report, first of all, you notice that there are only 3 rows. This is because that a non-empty filter. So as it turns out, we don't have any transactions for the components product category. So by default, we don't show it, even though it actually exists in the underlying table. Similarly, we don't have any sales for those unnamed product categories. So for those products which the product category has not been added yet, they also happen to be no sales in the sales table. So we don't show those 2 product categories because by default, the non-empty filter will remove them. Of course, if you want to show them, you can use the nice feature we call the show items with no data. So in which case, the other product categories will be shown to the report and they have no sales. By the way, in BI, as I said, no sales is not 0 sales, but blank sales. The non-empty filter only remove blanks. They don't remove zeros. But for some people, I have seen, not in this particular report, but for many reports, people don't want to show blanks in their report. Unfortunately, currently, there's no UI feature for you to say, I want to show blank as zeros. So many people use a DAX to achieve that. So there are multiple ways to do it. Here, I'm showing you one way. I need to go up. So here is one way to do it. Yes, you do a sum of sales amount plus 0. Okay, so plus 0 means when it's a blank, blank plus 0 equals 0, and 0 is not blank, by the way. So many people use this trick to show, in order to convert a blank to zeros, but it has a side effect. In this particular case, if I add this measure to my second report, you will see that the actually, let me first, you will see that you will see all 5 rows now. You no longer have the Power BI no longer remove components under the blank product category because, as I said, the non-empty filter doesn't apply to 0. It only applies to blank values. In this small report, it may be okay. It's not too bad. But if you have a really large report, especially if you have millions of, if you instead of at the product category level, you show it at the product level, then we're going to produce 1 row per product, even though maybe only a small percentage of the products only have sales. Then you will still see all of them. So not only is it ugly, more importantly, it can be resource intensive because Power BI need to actually produce such a large result before it's sent back to the report. It can be very memory, it's a big memory hog. And if you add a couple of columns, then there's going to be a cross-joining. For example, if you add product and customer to your report, then you're going to get all the combinations of product and customers, and most of them will return a 0 instead of a blank, which will be automatically filtered out. So some people run out of memory simply because they were doing this trick in Power BI using the +0. Go back to the slide. Okay, so so the lesson we learned here is this converting blank to 0 thing really should be a UI feature, right? DAX is fundamentally a calculation and analytical language. It's used for you to produce calculation results. This is really not supposed to be used for the UI purpose. So you guys, if you you should really vote for a feature, an idea in ideaspowerbi.com to say, okay, please add more formatting capability in the UI on the UI side, so to display blanks as a zeros or any other things or NA, whatever you basically a user supplied display value, but the underlying data query should return exactly the same thing instead of returning different values on the DAX side, which will actually change the number of rows sometimes that will be returned to the visual. That it has many unwanted side effects. And the last thing about the blank is blank in DAX is treated as equal to 0 and false. That makes sense because it's for people who come from the SQL background. In SQL, many people think of blank as a nulls, right? But blanks actually is not exactly the same as nulls. Nulls in SQL means unknown. So if you have a cell, if you have an amount of cells is a null, that actually means that I don't know the amount of cells. It doesn't mean that there's a 0 cells. But in BI, we decided to choose a blank to mean 0 because when you have a combination of a product and a customer, you have a blank cells. Most people means that I have 0 cells. So I can do comparisons. Like say I want to do a filter, anything is less than like a 100, that actually should include this guy instead of showing me unknown for this product category, for this combination of product and the customer. I don't know the cells. That's not what it actually means. But unfortunately, while it makes sense to treat a blank as equal to 0 for measures, we also extended, and some like numerical columns, we also extended this basically universally to all equivalents of blanks from the programming language perspective. Therefore, blank is compare equal to 0 and false, or even empty string, or the origin of date. All these kind of things, in my opinion, some of the design is questionable. And for the categorical columns, a blank should really be treated as a null instead of treated as equal to the origin. That's not what the user has intended, but it is what it is. So if you use the equal comparison operation, many of things will return true. For example, if you write if blank equals 0, it will return true. But of course, people don't write this. People say if column equals blank or 0, some people are surprised by the fact that both blank and 0 are actually returned true. And similarly, if blank equals false, it's also true. Blank equals empty string, also true. And you can use is blank, which to detect the whether or not it's a true blank or not. Is blank only returns true when it's a true blank. It's going to return false for 0, false, or empty string. And the DAX in operator is a strict operator in the sense that it will not match blank to 0. It will only match blank to actual blank and 0 to actual 0. Similarly, the DAX switch function is also using strict comparison. It's only just the equal operator, and the similarly, the greater than or equal, less than or equal, or less than greater than, all those are like a basic comparison operators. They were using this equivalent value comparison logic, while some DAX functions like is blank or the in operator or the switch function, they happen to use a strict comparison for the blank values. So this is a corner case, but you may want to know this just in case you run into something you have to scratch your head for a few hours and don't understand what's going on there. So we are at exactly 1 hour mark. I just have one more topic, then we will be done. So it's a good thing we have reserved 2 hours, so we have a little bit extra room to cover one last topic. This is the time intelligence functions. Time intelligence functions is one of the most powerful DAX functions and the most widely used. It's also the most confusing functions in DAX. So the first thing we should know that, just like we said last time, we said that DAX functions come from 3 major categories: from Excel, and from SQL, and from MDX. Okay, the time intelligence functions belong to the MDX category. What it means? It means they manipulate filters. All the MDX is the distinct feature of MDX is it can define measures that you cannot do in Excel or in SQL, and the measures is picking up the surrounding filters, and the time intelligence functions are actually filter manipulations. While Excel also have date functions. For example, they have a day, e-date, yield month, and the Excel functions are used to manipulate individual date values. So first some basic knowledge. The first one is the DAX store all the dates as a sequential number, starting from the origin of date, that is December 30th, 1899. Why do we pick such a weird starting date? We are following actually Excel tradition, because remember, we directly took Excel's library code, and this is even though Excel's official document doesn't say so, but it's actually because of some historical reasons, December 30th, 1899 is the origin of Excel data. Therefore, it's the origin of DAX dates. So many of the Excel functions like a date and the time function, and internally Excel is also representing dates as a sequence number from the origin. So DAX have the same tradition, whereas the whole number part of the sequence number being the total number of days starting from the origin, and the fraction part is the fraction of a day. And most of the Excel functions can be used to extract, let's say, you can extract a year, month, or quarter from the date value. You can construct a new date values from the parts. Let's say I can say date 1899, 12, 13. So I use 3 different components to construct a new date. I can convert the text values to dates. I can shift an individual date value, okay, and produce a new date value, and I can do a whole bunch of things. But all of those Excel functions are operating on individual date values, while the time intelligence functions, they work on a date column because they are manipulating filters, and the filters are in DAX are all actual column values. And so also the time intelligence functions cannot produce new dates. So you can say, oh, I have the date add function. That's a really convenient function for me to add, for example, a year to the existing date, and then I produce the date a year from now. No, it doesn't work that way. You can only produce dates if those dates also already exist inside your date table. So for all the time intelligence function, it actually is just shifting dates from certain set of, typically the current set of dates, to either a past or future set of dates, and then using the new dates as a filters to compare, to calculate the measure results. Let's look at a concrete example. Here I have a DAX expression, what it says is I'm using the add columns function to add a column, and the summarize function in this case you can think about as a group by. So summarize of the date table, year and the quarter is literally just give me all the distinct combinations of year and quarter in the date table. So I'm getting a list of a year and quarters, and then I add a new column to this table of 2 columns, and this new column is calculate the sum of sales amount. I'm using one of the time intelligence functions, same period last year. And in order, you may not know exactly how it works, but from its name, you can tell says I'm trying to get for the year and quarter. I'm trying to get the sum of sales of last year same quarter, right? So that's what it sounds like it's doing. So let's say how exactly it's doing. First of all, I started from a table of 2 columns, year and quarter. In this database, I happen to have 2 years, 2012 and 2013. Therefore, each year has 4 quarters, so I have 8 rows. And the add columns is one of those iteration functions. It's going row by row and then calculating this new column expression. So I'm going 1 row at a time, and for example, this highlighted row happen to be on this row. Okay, 2013 second quarter. Let's say I'm on this row, and I need to calculate this expression, calculate sum of sales amount same period last year. All right. So here's what happens. First, last time we said that the calculate function does one thing, is to convert a row context into filter context. So it moves the current row 2013 second quarter into a filter. Now I have a new filter, okay? Year, quarter. By the way, the same period last year is going to produce a list of dates. And what's the list of dates it produce? It's going to produce the same period, which is the second quarter last year, which is going to be 2012. So what it returns is, instead of a quarter and a year, it actually, all the time intelligence functions work at date level. It always produces a list of dates. So what it does is it returns all the dates in the second quarter of 2012. That is from April 1st all the way to June 30th. Okay. And also, once this new filter is added to the filter context, the existing filter is removed. This is a special thing of time intelligence function. Okay, time intelligence function will remove the filters, existing filter. Why? If I don't remove it, then I will have conflicting filters. I will have a filter of 2013. I will also have a filter of a bunch of dates in 2012. So you cannot possibly have the same sales table that can survive both filters. So you can only apply one of them, and obviously we want to apply the new filter. So the new filter will override the old filters. Now I'm using the new list of dates, which is April 1st all the way to June 30th, 2012, to calculate the sales. So each sales row will be used to match against to say, is the sales date happens to be one of the days? If so, I keep the row, and all the surviving rows will go through the sum function to do the aggregation function to sum of the sales amount for that particular days. So this is how DAX time intelligence functions work. They do filter manipulations. Right? So they take existing filters related to date and then produce a new filter, which is always a list of dates. Typically, you do some type of shifting either into the future or into the past, and then the new filters will override the existing filters and use to calculate whatever you want to calculate. And last but not least, I want to say that because the time intelligence functions, they currently work at whole year, the year, quarter, month, and the individual date level. For example, it doesn't work at a week level, and also it only works at the regular calendar. So if you have one of those like a 445 and those like a retail calendars, you have to do your own time intelligence functions using the calculate function, like we have shown before. Time intelligence functions is effectively a calculate function by setting the correct date filters. And because our built-in time intelligence functions work at a year, quarter, month, and date level, and they have to make sure that they do data shifting, they better shift them as a whole. Also remember, they also shift individual days. They don't shift month. They actually shift all the days in a month. So sometimes you see an example saying I cannot do certain things. That's because you are not shifting a full like a month or a full year worth of dates. Let's say one example. This used to be a much more prevalent problem, but since then we have did some improvement to DAX. So this error, this confusing error is much less likely to happen nowadays. This will be our last demo of the day. And let's go to actually this not be. I added one more demo since I have 2 hours, so I decided to show one more thing. Okay, so in this report, I have added a line chart. In this line chart, I have a bunch of months. I added a bunch of year months, so I'm showing total sales over year month. Okay, and I also happen to have 2 slicers. One slicer allow me to select 2 years, 2012 and 2013, which have data because I don't have a lot of data in other years. And I also have another slicer showing me the weekdays. So being as powerful as it is in DAX, I can actually select the individual days. I want to see all the sales on Saturday. And let me select Saturday. Okay, finally. So now I'm showing you the Sunday sales over different months in 2012 and 2013. I can also show, if it lets me click on it. Hey, Power BI respond. Something that my click is not okay. So that's a Saturday sales and a Sunday sales. Why is it so slow? Okay, the UI is taking its time to think. I don't know why. We're not seeing any of the DAX queries. They're not coming in. Okay, they're coming in. Yeah, the UI just, okay. So for example, I have selected a Saturday and a Sunday and a slicer, and this report nicely respond to my new filters. It's showing me the monthly sales over the 2 years, but only account for the weekend sales. Really nice. And that's because my measure happens to be a basic measure. It's a sum of sales amount. All right. So let me clear the filters. And now if I add a time intelligence function, so the time intelligence function is I'm using same period last year, and I'm calculating total sales same period last year. So if I now add this to my report, you can see the black line is the last year's sale. You can see it's the black line here in the 2013 is very similar to the 2012, right? Have the same shape of 2012. That's what it's supposed to mean. And because I'm going to the last year's sales, I'm comparing year-over-year sales in the same period. But for this report, if I try to do the same thing, if I only want to do the weekend sales analysis, what's the UI thinking? Yeah, there's no query here. We're not running anything. The UI is spinning here for some reason. Okay, so finally, as you can see, now I got an error. If I look at the error message, it says the same period last year, this function expects a continuous selection when the data column come from different. It's because by selecting Saturday here, I'm breaking up. I'm introducing gaps in the selected dates, right? I'm selecting I'm selecting all the Saturdays and in the selected period. But when I'm trying to shifting the whole year, I'm not getting the full year of states. And the DAX engine, when they do shifting, because it will always work in the like a whole month or a whole year, depending on what the function does. It depends on time intelligence function. So in this particular case, it's trying to shift the whole year, but it says I don't have the 365 days, so I can't do it. So it raises this error, right? And so this, as I said, I'm only showing this because some people still run into this particular error. They get confused, but this particular error, this continuous data selection error, only happens to time intelligent functions due to the nature how the time intelligent functions work. Last but not least, let's go back to this. So now that we know time intelligence functions are always working on a calendar table, the reason you need a calendar table is you are manipulating filters, and the filters better exist. You shift the days to the past or to the future, but those days must exist inside your calendar table. Otherwise, it doesn't work, right? And also, the calendar table better have the continuous list of days. Some people like to use for example, the sales date come directly from their transaction table. Sometimes it works, sometimes it doesn't. It's for the same reason. As I said, it has to work on dates that actually works. So some people, I've seen customer complain that how come my report doesn't work? And when I go to the previous month, I'm comparing the current month, which is literally March 2019. It turns out that they are using the date column directly from their transaction table. Obviously, they only have the transaction up to the current day in March. They don't have any future days. And then when the DAX function try to shift them over, it's not that they are shifting at the date level, but they have to collect all the days in a month. So they will find out that they only have a partial month. So when they go back to, for example, February, they try to compare to the previous month, they would only, but it found that you have all the days in March because you don't have like 31 days. You only have let's say 19 days. But the DAX engine doesn't know that. It thought, oh, these are all the days I have in the underlying calendar, so I want to compare to the entire month of February, which is absolutely not what you want. You want to compare to the same period, the same number of days in February, depending on your business logic. But in any case, what I'm trying to say is if you don't use the date column from the calendar table, which is a dedicated, full-fledged, no-gap date calendar table, you are using the date column directly from your transaction table, you may run into nasty surprises. So to avoid that, and also to give people a nice default date hierarchy, the Power BI automatically produce a calendar table for you by default. But how come you don't see it? Because they are hidden from you. This will be truly our last demo. So let me open a new Power BI desktop. So let me just I want to show you to create a new model from scratch, and then you will see that I don't introduce any calendar table, but somehow they show up by themselves. Okay, so let me create a new model from scratch. I select the AdventureWorks database. I select, let's say, fact internet sales table, and for illustration purpose. So you can see in the fact internet sales table, I have some data column called, I have several date columns actually. I have order date, due date, and ship date. I have a 3 dates column. And let's say I also happen to add some product table. Let me add the product table to it and the customer table to it. Notice that I deliberately ignored the date column, the data table of, no, not the employee table, but the customer table. So if I load these 3 tables into my report, I'll import data. So you can see I have the 3 tables in my report, and I deliberately skipped the date table, but I seem to be able to do analysis immediately. So I can produce a report, a line chart, and I can add the date table, or let's say order date, directly to my report. And I can do, let's say, I want to say the total sales over time. Say this is total sales over a year. I have a nice hierarchy. I can go to the quarter level. No, I wanted the year and quarter. I can go to quarter, year, quarter. I can go to month level, right? So I already have a automatic data hierarchy, and I can do analysis. Can I also do time intelligence? I seem to be able to do too. Let me add a new measure. I'll call it Y2D sales. And I will say using this time, let me use total Y2D. And the sum of, I'm typing too fast for intelligence to kick in. Sum of sales amount. And I don't have a date column, but I remember I was using order date. And you can see, first of all, you notice that it has the DAX intelligence automatically show me this dot notation. So if I see enter, it will actually automatically append a dot date to it. I don't know what it is, but I'll add it anyway because the intelligence automatically added for me for some reason. And then I'll add the new measure to my report. Where is my new measure? Where do I add it? Okay, let me find where my Y2D is here. Add to my report. And yeah, it just looks like a Y2D cell, right? It grows, it basically drops at the turn of every year, and then it grows steadily throughout the year. So it is a nice Y2D measure, right? How does it work? I don't have a calendar table. And did I lie about it? The fact that you need to bring always a date table, otherwise time intelligence function doesn't work. No, that's not true. It's because the DAX engine, it's not the DAX engine, it's the Power BI UI client automatically added a hidden calendar table for each date column inside your model. Right? So if I save this model, I call it demo auto date. I create a file called demo auto date. I save it. I close the file. I open desktop again. This time I'm using a trick. I want no, that's the wrong one. That's the wrong command line argument. This is the right one. So let me close this one. Don't save. So the first launch will raise an error because I used the wrong command line for a different purpose. So, but the second launch will be successful. So I have to do 2-1. The first one will raise an error. See, it says cannot load model. That's because I didn't launch it correctly. Let me close it. The machine is very slow. The second one should work, but if I can close the first one. Okay, the second one, let me open that file we just saved again. The file we just saved is demo auto date. This time, since I set a flag to turn on to show all the tables that are actually in the model instead of so you can see in addition to the 3 tables we saw last time, the fact, internet sales, dim product, and the dim customer, I have a whole bunch of local date table. All these local date tables is because there are multiple date columns in this model, and by default, Power BI will automatically create a date table for each of your date columns. And that's why also you have the nice automatic data hierarchy, and all the time intelligence functions can start working. But you have to remember to use the DAX dot syntax to make it work. And some people say, no, please don't do it for me. I want to do it myself. I can bring my own data table. I know what I'm doing. Then in that case, if you turn it off, you can just go to options, and go to data load and turn off uncheck the auto date time under time intelligence. When you say OK, you can see my time intelligence measure stop working. And if I remove it, it will go back to work. But it no longer give me the data hierarchy, it give me individual dates. And also you can see I only have 3 tables now. All the local date table have been removed. Now it's time for you to bring your own date table and connect them to your transaction table, and then perform the time intelligence against your own data column, your own calendar tables, instead of relying on Power BI's internal one, which is pretty, depending on how many data columns you have and the range of date, it can actually add quite a few more tables to your model and dramatically increase the size. So some of the, like I remember some people when they compare Tableau to Power BI many years ago, they said, why is Tableau model so bloated? It actually turns out that he has some date column that has using some special date to mark invalid dates. So the internal date table happens to produce a really large internal hidden date table. And also he happens to have hundreds of date columns in his report. And therefore we create hundreds of hidden date tables. And but if you simply turn it off, actually the Power BI's compression can be very impressive, can produce a much smaller file. So this just to let you know that to facilitate out of the box time intelligence functions and data hierarchy, we have this feature that automatically create calendar tables for you. If that's not what you want, just to turn it off. So that will be, yeah, we have used about an hour and a half. So this will be the end of my presentation.
All right, thank you, Jeffrey. Just going over quick questions before we end the webinar. We had one going back to your slide about the blank and his blanks. If you can see the questions thing in your webinar?
Let me.
I may have assigned one to you.
Let me take a look. Where under the questions, show questions. Why is the screen so small? How do I make it look bigger? Okay. In my experience, it doesn't return true, but when the what doesn't return true?
Is blank related RI error?
Can you address is blank related RI error? What does it mean? I'm not sure exactly what this question is referring to.
Okay.
In my experience, it doesn't return true, but when the RI reference is materialized in a column, then is blank returns true when referencing that column. What does that mean? Related.
Relational integrity, I'm assuming.
Yeah, but I'm trying to see what this question is asking. So one of the ways for people to detect, let me see, maybe he's asking about this. Okay, so in my report, let me first close this one. This is no longer what I want.
I guess they said if you reference a related column that returns blank due to an RI error.
Yeah, I remember we had a bug, but I thought that bug was fixed a long time ago. Yeah, we used to have a bug that if you do a is blank on top of related, there's a bug in there that is not returning the correct result. But I thought that was fixed. If it's still a bug, then you may want to send it to me directly. I can investigate. So yeah, we used to have some bug in the is blank of a related function, but I remember that was fixed a long time ago. I don't know if this question is about that bug or not.
Alrighty. Yeah, they said they'll retest it. I guess they'll email us back about it.
Yeah.
Alrighty. Well, I guess we can finish that up. Thanks again, Jeffrey, for doing the second part of the DAX. And thank you, everyone, for attending.
Okay.
Like
Thanks for
always,
having me again.
yep. Like always, we're recording the session. And Jeffrey, if you don't mind, maybe sharing out they may ask for the PowerPoint slides.
Sure. I'll give it to
So
you.
if we have that, you can give it to me, and I can send it out to our group.
Okay.
And then everyone that attended and who missed it, I'll try to get the webinar uploaded on our YouTube channel. And if you missed the first part of it last week, 2 weeks ago, that is on there as well. So I'll send you guys, everyone, an email probably in the next couple days. All right. Well, thank you again, Jeffrey.
Okay. Thanks. Have a good day.
Bye, everyone.